So here's just an extra video to help with graphing absolute value functions, because this is a really important concept and skill that you need moving into Algebra 2. So we're just going to talk about it a little bit more and also get some key vocabulary that I want you to write in your notes. So I'm going to give you vocabulary, I'm going to give you key graphs and just like steps so that you know exactly what's happening when you look at an absolute value equation, what the different parts of the equation are indicating for the graph. Our first vocabulary term is absolute value function. So this has a V-shaped graph that opens up or down. The parent function for the family of absolute value functions is y equals the absolute value of x. Sorry, that's kind of on the line. But it's y equals the absolute value of x. And that parent function on the graph looks like this, except this isn't exact coming off that graph because my finger, I can't get it exact. But the slope of this line is m equals 1, and the slope of this line is m equals -1. So if we were drawing just y equals x, that line would just continue to extend this way, right? But this here, x is negative and y is negative, right? So since it's absolute value, since we're talking about positive, we just reflect this line here so that it becomes this line. So absolute value is always a V-shaped graph that opens up or down. So y equals the absolute value of x is going to look like this. If we had y equals the negative absolute value of x, that's going to be facing this way. Okay? So it's, you take the absolute value, then it's negative, so it's facing down. So anytime you have this negative symbol outside the absolute value here, no matter what all is inside the absolute value, you know that your graph is going to be facing down like this one. So again, this v, right, or this negative right here, that negative sign outside the absolute value symbols, that's what determines whether your graph is facing up or down. If there's no sign, so it's positive, it's facing up like the yellow graph here. If there's the negative symbol there, then it's going to be facing down. So that's what that sign affects, whether your graph is opening up or opening down. So our next vocabulary term is translation, and a translation is a shift of a graph horizontally, so that's horizontally is along the x-axis, right? Vertically, that's along the y-axis, or both. The result is a graph of the same size and shape but in a different position. So if we want to graph y equals x, right, or y equals the absolute value of x, it's about like that, except this is exactly, this slope of this one here is m equals 1, and the slope of this one is m equals -1. So my graph, with my finger, it's hard to get it exact on here, but that's what it should be. So y equals negative, or absolute value of x. What if I want to graph y equals the absolute value of x minus 2? Well, this graph, oops, not there, right here, y equals -2, looks like this. So then what can you infer about this -2 here? Well, the graph shifted down on the y-axis, right? So this part of an absolute value equation determines the vertical shift. All right, so vertical shift. And it takes the sign that's there, right? It says -2, and it shifted down 2 on the y-axis. And when I say it, I'm talking about the vertice of the graph, or the vertex of the graph right there, right? So it shifts down 2 on the y-axis. Nothing else changed, right? Right in there, there was no negative sign, so it was a positive outside of the absolute value there, so I know that my graph is opening upwards, and that's it, right? So my graph looks exactly the same, except I shifted down 2 on the y-axis. So again, this, whatever's happening outside here, not it's being added or subtracted from the absolute value term, which is here, this is affecting the vertical shift. So if it was positive 2, I would have gone up to where y equals 2 and had my graph there, right? That would have been y equals the absolute value of x plus 2. So let's look to see what affects a horizontal shift. So here's y equals the absolute value of x, right? Y equals the absolute value of x. Well, what if I have, or I want to graph y equals the absolute value of x plus 2. So here my 2 is inside the absolute value sign, right? So if it's inside the absolute value sign, this is what this graph looks like. So you notice, it says plus 2, but my graph moved 2 places to the left on the x-axis. So from this, we can decide when there are numbers inside the absolute value sign, those numbers affect the horizontal movement, so the movement along the x-axis of the graph, but you take the opposite sign. So if it says plus 2 on the inside of these absolute value symbols, then you move it 2 places to the left. Likewise, if you have y equals the absolute value of x minus 2, that's going to look, you just move the original 2 places to the right because it's x minus 2, so that's affecting, we know it's going to move 2 spots along the x-axis, but in the opposite direction. So remember, if it's inside the absolute value symbol, it's the x-axis movement, and you take the opposite sign. But if it was outside, if the movement was out here, you know, or out here, adding or subtracting, then it's vertical movement, and it's the same sign. So you should have these written down. Horizontal movement, that's really messy, movement. So it's the x-axis, and you take the opposite, you move the opposite direction of the sign. So to keep, so far we haven't talked about anything as far as the lines, the V like getting narrower or wider, right? So you move your vertice, the vertex of the graph, and then you can also just pick 2 other points, like say here and here, and just move each of those 2 places over as well, and then you can draw your graph through it. Okay, so now we're going to look at an example that combines everything we just talked about, the 3 different parts of the absolute value function, okay? So let's graph y equals negative times the quantity absolute value of x minus 3 plus 5. So if it helps you to graph the original equation, y equals the absolute value of x, go ahead and sketch that on your graph when you do it. Okay, so let's look at our different parts here. We have the negative symbol here, right? So what does that tell us? That tells us our graph is going to be facing down, right? That's the negative sign. So our graph is going to flip and be facing downwards. Everything else is the same. Like, we just treat it the same. It's just flipped downwards. And then what does this x minus 3 tell us that's inside the absolute value? Well, that's horizontal movement, right? And you move the opposite direction of what the sign is saying. So it's x minus 3. So typically we would think we were going to move to the negative side of x, but we're going to actually add 3. So 1, 2, 3 here, right? That's the x minus 3. And then this here, that's our vertical movement, right? And we take the normal sign for that. So we'll go 1, 2, 3, 4, 5. So we're there. Our slope is still the same. It's 1 and negative 1. Okay, so have I graphed it? What did I forget? It's supposed to be flipped upside down, right? So we go there and there. And my vertices should be at 1, 3, and 5. That's where the vertex should be there. Okay? So it's flipped upside down because of this negative symbol. We shifted the original 3 places to the right because this inside the absolute value determines the movement along the x-axis, the horizontal movement, and you take the opposite sign. So since it said minus 3, we moved it 3 places to the right, to the positive 3. And then we shifted it 5 places up from there because that controls the vertical movement, and we just take that normal, the sign that's given, and that's the direction we move. Okay? Now, a few more vocabulary words. So a piecewise function is a function that has different rules for different parts of its domain. And the absolute value function is an example of a piecewise function. So, for example, what this means, a function that has different rules for different parts of its domain, when x is greater than or equal to 0, the absolute value of x is equal to x, right? Because this right here is saying when x is positive, the absolute value of x is x, because when x equals 4, right, because that's greater than or equal to 0, the absolute value of 4 is just 4, right? However, when x is less than 0, the absolute value of x equals negative x, right? Because if x is less than 0 here, that means it's negative. So when x equals negative 3, so the absolute value of negative 3 is not equal to negative 3, right? It's equal to negative 3, which is a positive 3, because the absolute value of any negative number makes it just the positive, right? So these are 2 different rules for when the domain is different. Remember domain here, that has to do with the x values, right? So it's different rules for different numbers, and that makes it a piecewise function. Think about piece, it's in pieces, right? The function has different pieces of the function have different rules. So if you can just remember that it's different parts of the function have different rules. For different values of x, there are different rules given absolute value and just the nature of absolute value. So that's what you need to know about a piecewise function, and you need to know the absolute value is a piecewise function. Now I want you to check your understanding and see how much of this you're getting and if you're struggling with things. So go ahead and do the lesson check on page 348 and just hit pause on the video, and then when you're done, come back and hit play. So go back into your notes, and hopefully you've written down, you need to have written down all the different parts of the absolute value function and how it affects the graph. And there are your answers to the lesson check. Okay, so if you missed some, ask questions. Otherwise, go ahead and get started on the practice exercises for 5.8. And here is your 5.8 assignment. So page 349, numbers 7 through 47, odds, skip 31. You don't have to do 31, and you're just doing the odds, and then check your answers in the back of the book. So 39 through 47, that's more of a review, just keeping your skills sharp. And this will take a little bit of time because you have to graph a lot of these, but you'll do great. You'll be fine.